Okay, let's take a look at section 12.6, quadratic functions. Everything we've studied so far have been linear functions. Quadratic functions is kind of like our first branch into looking at a whole bunch of other ones. Now in this course this year, we're only going to be we only mainly study linear functions, which we're at the tail end of now. In this lesson, notice it's from 12.6. We're just going to throw in a little bit so that you can see that there's other ones out there. There's quadratic, there's cubic, there's quartic, there's sine, tangent, cosine. There's a whole bunch of different functions out there. But like I said, we start with linear and then it builds from there. So this lesson's mainly just on seeing and recognizing different kinds of graphs that are out there. Mainly the second one that will be studied most often in years to come is quadratic. Now notice it has a different form. It doesn't look like y equals mx plus b. Instead it's ax squared plus bx plus c. So you're not going to have to memorize that, but just like y equals mx plus b, there were a few things that stayed constant. Y was constant and x was constant. Same here. Our y stays constant, and then these a, b, and c's can be replaced with numbers. Maybe 4x plus 5. And that's just a sample one. That's just a sample quadratic function. But notice my x's are constant and my y is constant. It doesn't change. That's not replaced with other things. Now, what makes it quadratic is a couple of things, but it's the fact, one, that we have an exponent in this, and not just any exponent, but an exponent of 2. Any function where the largest exponent is 2 is a quadratic function. Another thing that makes this quadratic is that when we graph it, we're going to get something that does not resemble a straight line as we saw with linear functions. Instead, we have two options. We're going to get either what almost looks like a happy face or something that looks like a sad face. Okay, either a happy face or a sad face. These happy faces and sad faces, though, just the U part of it, or the upside down U, this is known as a parabola. Okay, so these are parabolas, either like this or like this. Notice they're not straight lines, but they are symmetric. Mine here don't look too symmetric, but they are going to be symmetric. Okay, so now this is obviously a nonlinear function. It's not straight. And each of these parabolas are going to have either a maximum or a minimum. If it's a happy face, as we see here, this is going to have a minimum. It's the lowest point on the graph. Okay, it's the lowest point. So this has a minimum. If we have a sad face, then that point at the very top, that's our maximum. Okay, so let's try a couple. We're going to go back. The first method, if you remember, that we used to graph linear functions was the t-chart method, and that's what we're going to use here. It says evaluate the following quadratic function by making a table of values. I will give you the values. Okay, this year particularly, I will give you whatever x values I want you to use when you're making your t-chart. Again, this lesson here is only for like an introductory purpose. In years to come, you're going to learn a whole bunch of special ways to graph it. Because we can't use slope, there is not even an m in there. So there's different ways of graphing these ones, but the nice thing is a t-chart will always work. But I will give you the x values, because if you just choose random ones, it will work, but it's not necessarily going to come out looking like a parabola. So I don't want to cause you any extra stress. So let's go ahead. We're going to substitute our values in just like we did before. My equation, it's going to be 0 squared minus 4 times 0 plus 7. 0 squared is 0, minus 4 times 0 is 0, plus 7. My first output is 7. Now I'm going to do the next one. 1 squared minus 4 times 1 plus 7. I'm going to get 1 minus 4 plus 7. And all this over here is I'm just simplifying. 1 squared is 1. 4 times 1 is 4. 7. 1 minus 4 is negative 3. Negative 3 plus 7 is 4. I'm going to substitute in 2. 2 squared minus 4 times 2 plus 7. 2 squared is 4 minus 8 plus 7. Negative 4 plus 7 is 3. Next, I substitute in 3. 3 squared minus 4 times 3 plus 7. 3 squared is 9 minus 12 plus 7. Negative 3 plus 7 is 4. Ooh, notice we have a repeat. In this quadratic lesson, that's actually a really good thing. All right, now I substitute in 4 because that's my last t-chart value, my last input. 4 times 4 plus 7, I get 16 minus 16 plus 7, I get 7 again. Notice there's some you know, symmetry, like I said. And there should be. That's a good thing. All right. Use this table to make a list of ordered pairs. So this table, if we think of it, remember like our whole, when we talked about a function, this whole area almost goes away. These are my x values, my y values, they make my t chart. Okay, so I'll put that off just off to the side. Let's go ahead and list all of our ordered pairs. First one is 0, 7. Second one is 1, 4. Then I have 2, 3, 3, 4, and 4, 7. Now I'm going to go ahead and plot this, and this graph is kind of tiny, so I'll do my best. 0, 1, 2, 3, 4, 5, 6, 7. 1, 1, 2, 3, 4. 2, 3. 3, 4. And 4, 7 brings me back up. Oh, look at that. Notice it makes a nice, it says graph them, then draw a smooth curve through the points. Makes a nice parabola. Okay, if we continued to pick other points, they would all fall on that line. In this case, we have a happy face, so we're going to have a minimum. If they ask you that, which they didn't here, but if they do, that's how you figure it out. You look and say, well, there's a bottom point to this graph. There's not a top, because that will just keep going. But there is a bottom, we have a minimum. Okay? Now some people in other classes said, when are we ever going to need to know this? The common question. And often this is used in a lot of sports. It kind of models the projection of like a ball being thrown. This is like the guy throwing the ball. It goes up and comes down. You can see how far. You can estimate how far it's going to go, the maximum height it reaches. That almost looks like Snoopy. Okay, so let's erase our little diagram there. But that's often where it's used. All right, so example 2, evaluate the following quadratic function. I'm giving you the t values again. We're just going to go ahead and substitute them in. So for the first one, it's going to be 0 squared minus 8 times 0 minus 2. It's going to give me 0 minus 0 minus 2. I get negative 2. The next one, I substitute in 2. So 2 squared minus 8 times 2 minus 2. 2 squared is 4, minus 16 minus 2. 4 minus 16 is negative 12. Negative 12 minus 2 is negative 14. And I'm going to substitute in 4. 4 squared minus 8 times 4 minus 2. 4 squared is 16 minus 32 minus 2. 16 minus 32 is negative 16. Minus 2 is negative 18. This one should be 14 if I did it right, but don't just throw it in there because there's a chance maybe your other one was wrong and you don't want to mess it up that way. So this is 36 minus 48 minus 2. Negative 12 minus 2 is negative 14. Lastly, I have 8 squared minus 8 times 8 minus 2. I get 64 minus 64 minus 2, negative 2. So these point values I will give you, so you won't have to come up with them on your own. I'm going to make a table of values. 0, negative 2, 2, negative 14, 4, negative 18, 6, negative 14, and 8, negative 2. So let's plot these. 0, negative 2, 2, negative 14. I know that this goes to here, 13. 4, 1, 2, 3, 4, negative 18. I'm going off the graph. You could have counted by 2s if you wanted to also. 6, 1, 2, 3, 4, 5, 6. I'm going to be back up around here. And 8, 2, 2, 2, 4, 6, 8, negative 2. It's hard on the eyes. Alrighty, so let's connect it with a smooth, oops, that's not smooth. Connect it with a smooth curve. Sheesh. Try one more time. Smooth curve. That's a little better. Okay, we have a parabola. In this case, another happy face, but we notice that there would be a minimum. Okay. The next one we're going to skip. If you notice, it's the same inequality, or same equation, so we're not going to do it again. If you want to try it on your own, though, you're welcome to do that. Give it a whirl. Let's try. We have